Hey mathematicians, here are your notes for 1.6. We're going to be talking about solving compound and absolute value inequalities. So I've got the ACT up here, no worries about that for right now. Many medical tests or procedures require patients to be in a fasting state. Patients are in the fasting state when they have had no food or drink except water for at least 10, but no more than 16 hours. So let's describe this with inequalities using the acceptable number of hours for fasting as h. I know this is a little hard to read, that's why I'm reading it to you, but there you can see is h. So how many inequalities are required to describe the acceptable number of hours, and then what are they? Well, we know that the hours have to be at least 10, so greater than or equal to 10, but no more than 16 hours. So the hours have to be less than or equal to 16. So we have 2 here right now. However, you'll notice that because h is greater than 10 but less than 16, we could combine these 2 inequalities into one, where we say h is less than 16 but also greater than 10. So we really only need 1. We could write it in 2. So if we had to graph the acceptable range of hours, what would it look like on a number line? Well, let's draw our number line first. We can put our middle point. I usually don't add a ton of extra points that I don't need to. I just like to add about 5's usually good. 10 on my low end, 16 on my high end. And because h is in the middle of those, I'm going to say my one boundary point is 10, my other boundary point is 16, and then I'm going to connect those. Now remember, because these are or equal to's, we're going to fill in those dots. If they were just less than or greater than, we would of course leave them empty. That should be a review from Algebra 1. So let's look at some more of these. We have 3y minus 2 is less than negative 6. We're going to solve that one right away. Add the 2 over. We get 3y is less than negative 4. This one, I'm going to do this all in the same step, so I'm going to move that 4 over and get 2y is greater than 2. Divide both. I'm not dividing by any negatives, so there's no need to flip the sign here. That's another review from our Algebra 1. Remember, if you divide or multiply by a negative, we flip that inequality. All right, and then let's graph. Y is less than negative 4/3, but greater than 1. And if you don't want to put all those extra points on, you just want to label the important points, that is okay for me. Other teachers may have a preference, so make sure that you ask them what they prefer in their class. Greater than 1, it's or equal to. This one is less than 4/3, so I'm not going to fill it in. I also like to do my dots above the line so it's very, very clear what marks they're on. If you want to put these on the number line, just make sure your arrows are really obvious. All right, next up here, we have 5 is less than or equal to 2x plus 5 is less than 9. Remember, when we have these compound inequalities, we're going to do all the steps to all the sides. We need to keep it balanced. So I'm going to subtract 5 from the middle, but I'm also going to subtract 5 from the left and the right. When I do that, I get 0 less than or equal to 2x less than 4. Divide all sides by 2, again keeping it balanced. 0 divided by 2 is still 0. This becomes x. This becomes 2. Notice that x is nested inside of our 2 inequalities. So when we create our number line, 0 and 2, our line is also going to be nested in between them. That's the way that I think of it. You got 2 separate things going on. If you can't combine them to 1, you need 2 separate arrows. I could turn this into 2, but notice because I can turn it into 1, I'm nesting that in between. All right, you can go ahead and pause the video if you're super confident right now. Try that last one on your own. Otherwise, I'm going to go ahead and keep going with it. p plus 7 is greater than negative 2, or p minus 4 is greater than 8. I know this one was kind of hard to read, so I just copied over it. I'm going to subtract that 7 over and get p is greater than negative 9. Add the 4 over, p is greater than 12. All right, we got a little trickiness with that one, because if we graph it on the number line, we've got negative 9 and 12. But by the nature of being greater than negative 9, I'm also greater than 12. So that kind of negates that one. I don't need it as much, because when I write greater than 9, that arrow takes care of it. However, if this was an and statement, it would be a different case. If this was and, it would negate the lower statement, because you cannot be greater than 12 and negative 9. It would only be greater than 12. So just make sure you're paying close attention there. I know this is hard to read again, I apologize. How does this relate to absolute value inequalities? And you'll already see I threw in a little phrase here that says less is nest, more is or. This is a phrase that I use to remember what my graph is going to look like. Remember, when we have something inside the absolute values, it becomes two equations. I have x equals the positive version of what is there, and I have x equals the negative version of what is there. But because it's not just equal, it's also this less than or equal to, I have both less than 8 and I have less than negative 8. And notice when I solve these, I put this as the wrong thing. The negative should be over here. This should be positive 8, and this should be the negative side. My apologies. So when I solve this one, I'm going to get x is greater than or equal to 8, whereas this one is less than positive 8. Because remember, I can have a negative 8 in here, or I can have a positive 8 in here, so my inside can either be positive x or negative x. Now that I solved and I have my two sides, I can graph. Negative 8 on this end, positive 8 on this end. It is going to be less than or equal to that. I forgot to put my negative in there. And greater than that. So you can go through these steps every time, and I suggest that you do it to start off with. However, notice, because my absolute value is less than my result is nested in between my two values. Now my more is or comes into play with the next one. Same thing. I could have positive y is greater than 3, or I could have negative y is greater than 3. When I solve this one, I'm going to get y is less than negative 3. And then, of course, when I graph it, you're going to see that instead of being nested in between those two values, it is greater than 3 and less than negative 3. More is or. They go out. Or means out. So, I personally like to use the little mnemonic rather than solving every time. However, if you prefer to solve, that is totally okay. I also want you to make sure that you can show me this work on an assessment. I don't want you depending on this. I want you using it as a tool. All right, let's jump to the back and see some more of those. Solve the inequality and then graph the solution set. So right off the bat, remember that what is inside can either be positive or negative. So I can have x plus 2, the positive version is greater than 4, or I can have the negative version is greater than 4. Sometimes I put the negative on the other side. I think when it's an expression like this, it's a little bit easier to see the inside being negative. So let's solve. X can be greater than 2. Divide that over, so I get x plus 2 is less than negative 4. Move it over. X is less than negative 6. I can always check, which I should always do, and then once I do check, I'm going to graph. Both of those are not equal to. And just like my tool before, I'm going to double check myself. More is or, which means my arrow should go out. I'm good to go. I have checked it using my tool. Next one, we have the absolute value of 4x plus 1 is greater than 27. Remember, when we're solving these, we want to isolate that absolute value and then eliminate it. So I'm going to right away move that 1 over to the other side. Absolute value of 4x greater than 26. I don't have a problem here because this is not negative. We don't have any issues with that when working with inequalities. So now we go ahead and say the positive could be greater than 26 or the negative could be greater than 26. X is going to be greater than 6.5, or X is going to be less than negative 6.5. Check with both of those. I see that they both work. They don't cause any issues. Usually with inequalities, they don't. There's very rare cases. And then X is greater than 6.5 and less than negative 6.5. I check with my tool. I say more is or. More goes out, so we are good there. If you're feeling confident, go ahead and try those last two on your own. Otherwise, we will go through them together now. All right. Hopefully some of you paused the video. If you didn't, that's okay too. This one is already isolated, so we can just go ahead and jump right to solving it. Positive version, less than or equal to negative 2. Negative version, less than or equal to negative 2. I always miss my negative there, which is funny. All right. I right away notice when I solve this that I missed another negative, just like I said. Move that 2 over, I get 3x is less than 0, x is less than 0. Here I'm going to divide, so I get 3x minus 2 greater than positive 2. Add the 2 over, I get 3x is greater than 4, x greater than 3/4. All right, I've got two of my answers, except it doesn't work. I cannot have x is less than 0 and x is greater than 3/4. There is no graph for this one. This does not work. We cannot have both of those statements. Why is that? Well, right away, I know what I just said may not make sense to some of you, but I hope this one will. Look at your original problem. If you don't understand why this doesn't work, look right here. This little line underneath already should have tipped us off. So we can go through all the work, but this is why we check our answers, because if you check these, you're going to see they don't work very nicely. This or equal to is a problem. Remember, absolute values are always positive, so when we have an or equal to below and it says it might be equal to a negative number, we're already in trouble. So no graph for this one. If you need to see more examples of this or you're still a little confused, that's totally okay. Come and chat with me about it. Last one. This one is already isolated, so we're just going to go ahead and say x plus 2 could be less than or equal to x plus 7, and then the negative version, 2x plus 7. Solve it. I'm going to move the x over to the other side, 7 back, so x is greater than or equal to negative 5. Over here, distribute, and then move over, so I'm going to go ahead and do 2 steps in one. 3x plus 7. I get 3x is greater than or equal to negative 9. And then I'm going to flip this one around so that the x is on the left. I just prefer it. I'm going to do that in this step as well. So x is greater than or equal to negative 3. Notice this one was an and. Less is nest, so this is an and problem. And because it is both one and the other, when we create our graph as an and problem, we need to only follow the one that is not negated. So if this is, if it has to be greater than -5 and greater than -3, all numbers greater than -3 fit greater than -5, but not all numbers greater than -5 fit numbers greater than -3. So our graph is going to look like this. Again, check yourself. This is where that tool does not come in handy. That's why I don't want you relying on it. If we look at a less's nest, this would say that it's nested in between those two values, but it is not. We have to keep double checking our answers. So let me know if you have any questions. I'd be happy to help.